Hey guys, and welcome back to the second part of the Chapter 8 test review. I hope you took the little break and got a snack, got something to drink, maybe use it as a bathroom break, and now we're going to head back to reviewing. This time we're going to go ahead and start with the number 12. It's on the back side of the review. We're going to start looking at antiderivatives. Okay, so number 12 says to find the indefinite integral of 3 times the cosine of 2x dx. And if it's indefinite, what that means is you do not have the numbers on the top and the bottom. Okay, and that's what we'll see on the bottom. We'll get into some fundamental theorem of calculus. But when they say indefinite, it means you're just straight up finding the antiderivative. If you have a constant, like we do here, we have a 3. Go ahead and bring that 3 out front. That way, I am just finding the integral of the cosine of 2x dx. So I took care of that 3, brought it out front. Now the antiderivative of a cosine is a sine. So the 3 just stays out front. The antiderivative of a cosine is sine. You keep whatever the function was. So in this case it was a 2x, that 2x stays. Because this is more than just an x. You take the derivative of this, which is 2, but instead of multiplying it, you divide by 2, which is the same thing as multiplying by 1 over 2. These two terms can be multiplied together because they are not tied with the sine function. So I can take 3 times 1/2 and have 3 halves times the sine of 2x. It's an antiderivative, so please make sure that you remember that constant. Here's another one. This again is going to be that chain rule. When we find our antiderivative, we have to go ahead and find the derivative of the inside, and then you'll be dividing by that or multiplying by 1 over whatever that is, okay? So the antiderivative of the cosine of pi minus 3x. Well, first off, the antiderivative of a cosine is the sine. You keep pi minus 3x the same. Because this is more than just an x, you find the derivative. Well, pi is just a number. The derivative of a number is 0. The derivative of negative 3x is negative 3. So you're dividing by negative 3, which is the same thing as multiplying by negative 1/3. So to simplify this, it's negative 1/3 goes in front of the sine of the original, pi minus 3x. It's an antiderivative, so please make sure you add c. Let's look at one more of these. Now, secant squared, that was one of the formulas that we had. Okay, secant squared, the antiderivative of that is a tangent. So I have tangent of 1 minus 2x. Again, chain rule. The derivative of 1, it's just a constant, so it's 0. The derivative of negative 2x is negative 2, so I can multiply by negative 1 over 2. This negative 1/2 can go in front, so it's negative 1/2 times the tangent of the group 1 minus 2x plus c. Okay, now I know in the first part of the review as well as right now, I have talked about, the formulas. And so some of you may be questioning, do we get to see those formulas on the test? Yes, absolutely. You will have a cheat sheet that has your derivatives and your antiderivative formulas for you, okay? As we continue to move on in our mathematical knowledge and in calculus, just because they added trig functions, that doesn't mean that important things like the fundamental theorem of calculus go away. Remember, the fundamental theorem of calculus, what happens is now you have what's called a definite integral, meaning you have a definite starting point and a definite ending place. And so you still find the antiderivative like we did before, but then you're going to replace your variable with pi over 2, minus replace your variable with 0 and do that actual subtraction. So we're going to go ahead, fundamental theorem of calculus, the antiderivative of a secant is, or a secant squared is tangent. I keep x plus pi over 4, keep that the same. This is more than just an x, so I have to find the derivative of this. Well, the derivative of x is 1. The derivative of pi over 4 is 0. So it is going to just be a 1. So your antiderivative is the tangent of x plus pi over 4 plus c. Okay, so if you got that, perfect. But now that it's the fundamental theorem of calculus, you're going from 0 to pi over 2. Okay, and you can actually do this in the calculator. You just want to make sure that your calculator is in radian mode. And so I'm going to go ahead and show you how to do that. So I'm going to take my antiderivative, plug in pi over 2, minus, take the antiderivative, plug in a 0. And then I'll show you how you can put this in the calculator. So if I take the tangent of pi over 2 plus pi over 4 minus the tangent of 0 plus pi over 4. Now here, in order to add these two, you do need a common denominator because you're adding fractions. So I'd have to multiply top and bottom by 2, making this 2 pi over 4 plus 1 pi over 4. So this is the tangent of 3 pi over 4 minus 0 plus pi over 4 is just pi over 4. Okay, so we're going to go ahead and plug those in. Again, I said if you have your calculator, we are in radians here, so you want to make sure that your calculator is in radian mode. So remember, it's right next to that second key, you hit that DRG. Right now I'm in degrees. I want to go into radians. So I'm going to go ahead and go tangent. It opens a parenthesis for me. I want 3 pi over 4. If I hit enter, I get -1. So this is -1 plus c. That's what happens when you put in pi over 2. Now if I go tangent of pi over 4, because that's what it would simplify down to if I replace the x with a 0. So tangent, it's going to open parentheses for me. Pi over 4, again, we're in that radian mode. I get a 1. So it's -1 plus c. Well, positive c minus c is going to cancel. -1 minus 1 more is a -2. So what this tells us is if we were to graph the original function, if we were to graph the secant squared of x plus pi over 4, and we were looking on a coordinate plane between 0 and pi over 2, the area, it's -2. If it is a negative area, that just means that that portion of the graph, it's going to fall below the x-axis. But again, fundamental theorem of calculus, you still find the antiderivative like we have been. This is definite, means it has a starting point and an ending point. Once you know your antiderivatives, you put in the top value, fill in the bottom value, subtract the 2, and that's what your solution would be. Okay, another thing, if you want to find the slope of a tangent line, the derivative, and we talked about this way back in chapter 1, what the derivative is it is a formula to help you to find the slope of a tangent line. So even though we're looking at trig functions now, this goes all the way back to chapter 1. So 16 says, find the slope of the tangent line of this graph, e to the 3x times a cosine of x cubed at the origin. Remember, your origin ordered pair is 0, 0. If you are trying to find the slope of a tangent line, that means you have to find the derivative. So if I have e to the 3x times the cosine of x cubed, these are two separate terms being multiplied together. They both contain a variable. So in order to do this, this has to be the product rule. So product rule, I'm going to keep the first term the same, e to the 3x, times the derivative of g of x, which is our second term. The derivative of a cosine is a negative sign. I keep my x cubed the same. Because this is more than just a variable, I have to also multiply by the derivative of x cubed, which is 3x squared. So that's the first chunk of the product rule. Product rule, now you go ahead and add the second chunk. For the second chunk, you keep g of x the same. So I keep cosine of x cubed, times the derivative of f of x. This is an e term. The derivative of an e term, you just rewrite it. So it stays e to the 3x. But because this is more than just an x, you ignore the e, find the derivative of 3x, which is 3, and you multiply it. So now what I have to do is go ahead and see what we have in common between the two pieces. Okay, so this is a 3, here's a 3. This has e to the 3x, this has e to the 3x. So I am able to take both of those things out. I can take out a 3 and I can take out e to the 3x. This would cancel, this would cancel. What I have left is negative x squared, because it's negative in front of the sign. X squared is remaining, sine of x cubed. Plus, I took the 3 out, I took e to the 3x out. This is a cosine of x cubed. Okay, now that's your derivative. That's awesome. Okay, they didn't ask for the derivative. What they asked for is find the slope. This is the formula to find the slope. It's based off of the x value for the point that you want to find that slope for. They want to find the slope for the origin, meaning the x is a 0. So I'm going to change all of the x's to 0, and then we can go ahead and find our slope. So it's 3 e to the 3 times 0 on the outside, minus 0 squared times the sine of 0 cubed plus the cosine of 0 cubed. So if I go ahead and I look at this, e to the power of 3 times 0. This is going to be e to the power 0. Anything to the power of 0 is 1. So 1 times 3, this is 3. Well, notice this. I'm multiplying by 0 squared, which is 0 times a negative. There's no such thing as a negative 0. 0 times whatever the sign ends up being, it's going to be 0 because you're multiplying by 0. Now the cosine of 0 cubed, if you plug that in your calculator or if you envision that unit circle, the cosine is the x value. If you are looking at 0 on your unit circle, when x is 0, your cosine value is going to be a 1. Okay, so the cosine of 0 is 1. So now I can add those two. 0 plus 1 is 1, and 3 times 1 is 3. So the slope of this function, if you were to graph it and draw a tangent line at the origin at 0, 0, your tangent line would have a slope of 3, meaning it's going upwards, and you would go up 3 over 1, up 3 over 1 in order to continue your tangent line. Okay, so just reminding you that even though we are looking at trig functions now, things like finding the slope and fundamental theorem of calculus, they don't go away. It's just now we can do more advanced questions to go ahead and get those. Oh, sorry, I just realized I did this. Okay, so if I look at my unit circle at 0 degrees, that's where you stay right here. If some of you are saying, hey, how the heck did you get the cosine of 0 as 1? Remember, this is 0 degrees. Your unit circle, it has a radius of 1, and the cosine is the x value. Again, if let's say you did not take college trig last year, if you did not go ahead, if you plug that in your calculator, if I take the cosine of 0, you can see that it's a 1. But I just looked down and I realized that I started drawing the unit circle and I didn't stop. So sorry about that. The cosine is the x value. This would be the ordered pair at 0 degrees, which is what this is referring to right here. Okay, last question. Now this one's kind of crazy, okay? So it is a story problem, but we're going to be fantastic, I promise. In a large city, the amount of sulfur dioxide pollutant released into the atmosphere due to the burning of coal and oil for heating purposes is given by this function. Okay, so here is the function, and it's talking about the pollution. I have pi over 26t, okay? For the domain 0 to 104. Okay, so this formula is accurate when your variable is in between 0 and 104. The function is the amount of sulfur dioxide in tons. So whatever we get as our solution, we have to remember to label it in tons, released during the nth week after January 1st. How many tons to the nearest ton, so we're going to round to the nearest whole number, of pollutants were emitted into the atmosphere from 0 to 65, and that does fit into the domain because we can start at 0 and go all the way up to 104. We're only going to 65. It says use the fundamental theorem of calculus. Well, fundamental theorem of calculus is a definite integral. It starts at the lowest number, it ends at the highest number. So I would set it up, because it's fundamental theorem of calculus, I know it's an antiderivative. Where does it start? Where does it end? So 3 plus cosine of pi over 26t dt. So that would be your original setup. Okay, now if I'm doing an antiderivative, this is 3 because it doesn't have a variable. It has like t to the power of 0. If I add 1, it's a 1. Divide the 3 by 1, and I would just have 3t. If you find the antiderivative of a cosine, that is a sine. I'm keeping pi over 26t the same. This is more than just a t. So you have to take whatever this derivative is and multiply by the reciprocal. Well, the derivative is pi over 26. If you divide by a fraction, that's the same as multiplying by the reciprocal, which would flip and make the 26 go over pi plus c. So I can simplify this a little bit. I can take this 26 over pi and I can move it out front of the sine function. So I have 3t plus 26 over pi times the sine of pi over 26t plus c. And it's going from 0 to 65. So now what I have to do is go ahead and take my antiderivative, fill in a 65, find out what that value is, then fill in a 0, find out what that value is, and go ahead and subtract the two. If I put in a 65, 3 times 65 is 195. Plus, if I put in a 65 here, okay, now this gets a little crazy. So I have 26 divided by pi. That's what's out front, okay? Then it's a sine. If I put in a 65 here, this is going to be multiplying fractions. So it'd be the 65 pi over 26. Because if I fill in a 65, it's the same as 65 over 1. So it's the sine of 65 pi over 26. So I got 8.276 plus c. So when I put in 65, this is what I got. I can go ahead and simplify it by adding those two. 195 plus 8.276. If I put in a 65, I got 203.276 plus c. Now I'm going to go ahead and put in a 0. Well, 3 times 0 is 0. Plus, if I put a 0 in for t, it's going to make this a 0. So if I go ahead and I take 26 over pi times the sine of 0, I end up with 0. So this is 0 when I put in the 0 in this piece. I get a 0 when I put in a 0 for t here. This is c. I can simplify this. 0 plus 0 is 0. So here is how I'm going to get my final answer. Well, c minus c cancels. 203.276 minus 0 is 203.276. The question said to round it to the nearest ton, so the nearest whole number. I would have approximately 203 tons of pollutant being released into the atmosphere due to burning coal. Well, that is your test review. It does go through a whole bunch of stuff. If you have any questions, definitely jump on the Zoom meeting, and I am happy to help you out. Hope you guys are having a great day, and I'll talk to you soon. Bye.